In this video, we will be studying some properties of systems. So we are studying some properties of systems now. The first property that will be discussed in this video will be time invariance. And we will be studying linearity also. So this systems, the systems that is obeying time invariance as well as linearity, these are called linear time invariant systems, or you will call it as LTI systems, linear time invariant systems. So let us see what is time invariance first. Time invariance. So suppose that you are having a system, this is your system, and you are giving some input to your system. This is your input. The input is called x of t. Okay, when you give the input x of t to the system, you will get output. That means you are giving the input exactly at 0, time t is equal to 0. You will get the output also exactly at the same time. The output looks like this. This is your output y of t. Okay, now to the same system, you are giving the same input x of t, but after a delay. That means you are not giving your input now at time t is equal to 0. Instead, you are delaying the input by a factor of capital T. So, this is x of t minus t. You are giving the same input x of t itself, but after a time delay of capital T. So, what happens is that your output now it not appear at time t is equal to 0. This will also appear after a time delay of capital T, and you will get the same output itself. That means this is output and this is y of t minus t. So, time invariance means a system is said to be time invariant if the input-output characteristics of the system do not change with time. Okay, the input and output characteristics of the system, it will not change with time. It will not change with time. This type of systems are known as time invariant systems. Okay, so let us see some examples. So the first example I'll be discussing here, it is having the output y of t which is equal to x of t square. So this is the system output y of t is equal to x of t square. So you have to see whether your input output characteristics is changing with time. So how do we do is you delay the input and get the output, and you delay the output and watch the output. Okay, so first thing you will be doing is you are delaying the input. So what is the input here? X is x of t square. You delay this x of t square by capital T, and what happens? Okay, so you are seeing that your input is delayed by capital T and you are watching the output. Okay, so you have to write this like y of t comma capital T. This means that you are watching the output y at time t itself, but here your input is delayed by capital T. So what will be the output? It will be the input x of t square. This is delayed by capital T. Okay, so it is x of t square minus t. Okay, we will call it as equation 1. Then what is the next step you will be doing is you have to calculate the output. Okay, when it is delayed by a time t. Okay, so here in the previous case your input was delayed by capital T and you are watching the output y of t comma t. Your input is delayed by x of t square minus t, that will be the output. Okay, here what we'll be doing, the next step is you are delaying the output by capital T. Okay, you will call it as y of t minus t. That means wherever there is a t, you will have to substitute there t minus capital T, because you are delaying the output. So here you can see that it is x of t square, right? So you are watching a t there. So instead of t, what you have to do, you have to substitute t minus t the whole square. Okay, x of t minus t the whole square. You will call this equation as equation 2. Now you have to compare these two equations. If your system is a time invariant system, you will get these two as same, because for a time invariant system, the input output characteristics will remain the same. Even if you are delaying the input, you are delaying the output, doesn't matter, you will get the same output. Okay. So when you watch this, you can see that in equations 1 and 2, it is not same, because in equation 1, your output was x of t square minus t, and equation 2, your output is x of t minus t the whole square. These two are not equal. That is, 1 is not equal to 2. Or you can see that y of t comma t, that is the output that is watched after delaying the input by capital T, that is not equal to the output that is delayed by capital T. So you can call these systems as time variant system. Okay, so this is a time variant system. Okay, so consider another example. Second example is y of n is equal to x square n minus 1. So here instead of t you are having n, that means this is a discrete time signal. So the first thing is output that happened to a delay in the input. Delay the input by k. Discrete time signal, we can use the variable called k. So this delay the input by k and watch the output. So you'll call it as y of n comma k. Delay the input by k and watch the output. Okay, I'll write that. Watch the output. Y of n comma k will be equal to x square. You are simply delaying the input, right? Your input was n minus 1. You are delaying it by k, so it is minus k. So this is equation 1. Now watch the output after it is being delayed by t, or output is delayed by k. So what we'll call it? You will call it as y of n minus k. So whenever you see an n, you will have to substitute n minus k. So this is x square n minus k minus 1. Okay, now watch these two equations. This is n minus 1 minus k. This is also n minus k minus 1. Both are same, isn't it? Equation 1 is equal to equation 2. So what is the system? This is a time invariant system. This is a time invariant system. So I think you have got a clear idea about this time invariance. So I shall move to linearity now. So linear systems. Linear systems are those systems that obey the principle of superposition, and at the same time it will obey the principle of homogeneity also. So linear systems are those systems that obey the principle of superposition and homogeneity at the same time. So let us see what is the homogeneity and what is the superposition. Okay, so let me say what is homogeneity first. Homogeneity means that if you are having an input x1t and it is giving an output y1t, then an input of ax1t will produce an output of ay1t. That means if you are multiplying the input with a constant, the output will be the same output that is multiplied by the same constant. Okay, that is principle of homogeneity. Now let us see what is this principle of superposition. That means you are having an input x1t, it gives the output y1t. Then you are having an input x2t, it gives an output y2t. So when you add these two input signals x1t and x2t, x1t plus x2t, and you are giving this to a system, then the output will be the summation of y1t plus y2t. This is the principle of superposition. Okay, and a system will be linear if both these principles are obeyed at the same time. That means either superposition homogeneity or a samayam obey ചെയ്യുന്ന systems ആണ് linear system. That means function of a1 x1t plus a2 x2t will be giving a1 y1t plus a2 y2t. Okay, that means for weighted inputs, Weighted inputs or linear inputs, summation, it will give weighted output. Okay, so what are linear systems? Linear systems are the systems that obey the principle of superposition and homogeneity, or you can see that a function of a1x1t plus a2x2t will give the output a1y1t plus a2y2t. Okay, so consider one simple example. So I am giving you a first example. Y of t is equal to t square x of t. Y of t is equal to t square x of t. So let us calculate the weighted output first. Okay, for calculating the weighted output, we know that if your input is x1t, then what is the output y1t? That will be equal to t square x1t. And if the input is x2t, then what will be y2t? It will be equal to t square x2t. Isn't it? Now, what is the weighted output y3t? y1t plus y2t, what will be that? It will be a1 into t square x1t plus a2 into t square x2t. That will be a1 y1t plus a2 y2t, isn't it? That is a1 y1t plus a2 y2t എന്ന് പറഞ്ഞാൽ നമ്മളൊന്നും ചെയ്തിട്ടില്ല. ഈ y1t ന്റെ കൂടെ a1 മൾട്ടിപ്ലൈ ചെയ്തു, y2t ന്റെ കൂടെ a2 മൾട്ടിപ്ലൈ ചെയ്തു. ഇത് LHS ലും ഇത് RHS ലും ആണ് വരേണ്ടത്. So a1 y1t plus a2 y2t will be equal to a1 t square x1t plus a2 t square x2t. So this is the weighted output. Similarly, what you have to find out is a function of a1 x1t plus a2 x2t. So what you have to do here is, whenever you see a x1, you have to multiply it with a1. Wherever you are having an x2, you have to multiply it with a2. So what will be the result? It will be നമ്മുടെ input എന്ന് പറയുന്നത് it is t square x1t. But t square into a1 x1t plus t square into നമുക്ക് x2t കാണും, അതിന് മുമ്പ് a2 കൊടുക്കുക, a2 x2t. അപ്പോൾ ഇതാണ് weighted inputs, ഇതാണ് weighted output. നമ്മൾ അതിനെ equation 1 എന്നും equation 2 എന്നും വിളിച്ചു കഴിഞ്ഞാൽ, now you have to compare this equation 1 and 2. Compare equation 1 and 2. So when you compare this equation 1 and 2, what you will get? You can see that both these equations are same. This is a1t square x1t plus a2t square x2t, and this is a1t square x1t plus a2t square x2t. Isn't it? Both are same. So you can say that since these two are same, your system is a linear system. This is how you do the problem. Okay, thank you.